Okay, good morning from Zambia. This is 0035. Okay, so today's topic or lesson will cover what we call implicit functions. So, specifically, we're going to look at implicit differentiation. So, when we talk about the implicit function, it is a function which is having two or more variables, and it is difficult to make one of them the subject of the formula. In short, you are unable to isolate one variable. So we'll start with the definition. An implicit function so that is an implicit function. So an implicit function is an equation of the form uh, fxy equals 0. So this happens when it is difficult to make one variable the subject or one variable to be isolated. So then from there we'll go to what we are calling implicit differentiation. So under implicit differentiation, you are going to be given an implicit function. Then with that implicit function, you'll be told to differentiate a particular letter or a particular variable. So that is what we're going to deal with under implicit differentiation. You may be given an equation x equals x power 3 y power 3, then yeah, so such an equation, and then you are told to differentiate the function. Maybe you are told to find dy dx, so such functions. Or you may be given uh, x ln x plus y, and then you are told to find the dy dx. So that is what we are talking about. So we dive straight into the questions. So the first question that we're going to look at, so it's saying solve for dy dx if you have been given, for instance, we'll start with the a, which is x equals x squared y power 3. So that one is an implicit function. So that one is an implicit function, because you may make y the subject, but it will be difficult, or whatever you're going to make. So for instance, we want to find the dy dx. We can divide x squared. X squared can be divided from this side, and you can also divide it from that side. But in so doing, we can see that we are killing one variable for x. It is being killed via division. So this side, it will be eliminated. You remain with y power 3. This side, you are going to have 1 over x. Then from there, you are going to form cube root of y, and then cube root of, cube root of 1 over x. Then from there, we are going to yield, which is power 3. So from there, we can see the inside. the inside it's x equals like that, then those will multiply. But instead of going through this process and then you start to differentiate, so from there that's when you can start to differentiate. But with the use of implicit differentiation, there is a formula that makes it a bit easier than going through this process. You may succeed in one way or the other, but relying on a certain formula will be more useful than first evaluating and then starting to differentiate at last. So we look at the implicit differentiation formula. So for the question given, the first step that you may take is to write the formula. You are finding dy dx, so you say dy dx equals, so for the formula we have seen that y is on top and x is down, so their corresponding differentiations are going to be crosswise. So the only thing that will be involved is a negative, and then crosswise we write capital F with respect to x and with respect to y. So in such a case, this one is read as partial derivative of f with respect to x. This one is also partial derivative of f with respect to y. In short, there is a function which is having more than one letter or more than one variable, but you just want to differentiate x in that function. Again, the same function has got so for instance, this is the only one you've been given. It will mean that there is more than y, but you just want y. That is why we're saying partial, meaning just part of the function. So that is our formula. After writing the formula, you have to say let, then you check the number of variables which you have there, or how many, or what type of variables are there. We just have type x and type y. So we're going to form the function having x and y. So this function you have formed, let it just be equal to the question. So it should be equal to the question. So I've not made anything here. I'm just saying let this function be equal to your question. So it should always be equal to your question. So if you cut here, we can see that this is our question and it is the one which is here. So whatever you have brought in has just been equal to the question. Then from there, form the implicit function, the one which is equal to 0. So in simple terms, your question should now come in the middle here, or move this variable here, so that you remain with a 0 as the implicit function suggests. So this guy comes here, and then you remain with a 0. So that is the step to go about it. So after doing that, allow me to clean the top part. So since we have the function having x and y, we can now differentiate it. So that is where partial derivative of f with respect to x comes from, after you have got the function. So that's how it goes. So you have the question, you say let f of xy be equal to the question. From there, just move this term to the middle, because the implicit function suggests that there should be a 0 that side. From there now, let's follow the formula. What the formula said, it said dy dx equals partial derivative of f with respect to x over partial derivative of f with respect to y. So we are trying to find partial derivative of f with respect to x, and then we'll find the partial derivative of f with respect to y. So let's go to the function which we have and just differentiate it with respect to x. So that's what we're going to do. Where there is no variable that you're considering, then the answer is 0. That's how the differentiation is. If you are differentiating with respect to y, and where you have reached there is no y, then that entire term becomes a 0 under your differentiation. If you are differentiating with respect to x, and the term which you have found, there is no x, then that entire thing becomes a 0. So do not forget that point. We continue. We are differentiating with respect to x. So here there is x. We know how to differentiate. If there is only x, it means x is a power 1. So this one will drop, and then it will be 1 times the x which is there and its power, but reduced by what? 1. So 1 times x at the power of 1 minus 1, which is 0. We know that any number to the power 0 except 1, any number to the power 0 except 0, the answer is what? 1. So 1 times 1 gives you 1. So whenever differentiating a variable on its own and it's the one you're considering, then the answer is just 1. If it has a number, for instance, it is 2x. After differentiating it, we are going to say 2. If it has 7, it will still be 7. In short, a constant and a variable, if you differentiate, the answer is a constant. That is the case. If you have got 100x, if you differentiate with respect to x, the answer is just 100. So that is the rule there. Okay, we now go to this one. So here we have obtained a 1 minus. You are differentiating with respect to x, but this guy is attached, so you treat it like a constant. So let it just follow, but differentiate your variable. So 2 drops to the front, it will be 2, and then to that squared remove 1, it will remain x, and then this guy is attached, they are multiplying, so just take it like that. Then we have differentiated with respect to x, so that is the case there. Let's now differentiate with respect to y, as the formula suggests. So use a different color just to get attention of the brain. So we are differentiating the same function now with respect to y. So this is the point now. Here there is no y. So your answer is 0. So in this case, we just ignore it. I will not write 0, just so that there is a 0 there because of this, but I will not write it. We now come here. We are differentiating with respect to y. And our y is to the power 3. So this 3 will fall to the front. So we are having this, and then we are differentiating with respect to y. So this power of y will come in front. So it will be negative 3, x will just follow because they are together. And then to this power 3, remove 1. So it will remain power 2. Hence, our answer is 0 minus this one, which is just that same one. Hopefully, this is clear. We go back to the formula now. The formula is saying dy dx is equal to negative partial derivative of f with respect to x over partial derivative of f with respect to y. So let's fix what we have into the formula. So dy dx suggests that it's negative, and then what is our partial derivative of f with respect to x? So this is the partial derivative of f with respect to x. What did we get? We got 1 minus 2x y power 3 divided by our partial derivative of f with respect to y, which is this one, which is negative 3x squared y squared. From there, we wish to multiply, but there is a negative down here. So these two guys, they can humbly cancel out. And then we are going to remain with the top, which is 1 minus 2xy power 3 divided by 3x squared y squared. So by so doing, we have found dy dx. If there is anything that can cancel out, except in this case, you have to simplify. But in our case, I'm sure this is where the question ends.